This is an ongoing series on natural law and consciousness. We're looking at 14 methods of mind control, how consciousness is being subverted. We're looking at the 14th method, and in particular chaos sorcery. Chaos sorcery is a Hegelian dialectic, which is problem, reaction, solution. And I want to show today how unequivocally can prove that the events of 9/11, there are other forces in effect that day that caused those buildings to collapse. And this is an example of the Hegelian dialectic of a problem that was created in order to implement a solution that people would want after the problem had occurred. We will look at three basic physics equations to prove unequivocally that there were other forces in effect that day that caused those towers to come down. The physics of the event shows that this is a predetermined demolition of the buildings in a way that is undeniable according to laws of nature. Now, if you understand dynamics and how that works in the real world, then you can tell that you're being lied to. You don't have to take anyone else's word for it. You can just take the weights and the measurements and plug those into known equations and solve that for yourself. The physics of 9/11, or why the trade towers could not have come down according to the basic laws of dynamics, they have fallen at speeds which are observed to fall, which was 9.81 meters per second. This could not have happened unless other factors were at play at that day. So the upper floors of the building collapsed onto the lower floors, and we're told that this caused the pancaking effect of the building. And we observed that pancaking effect at the speed of gravity, which is 9.81 meters per second. And I'm telling you that this is impossible according to the laws of motion, and simple dynamics equations can prove this. There are three basic equations needed. Two basic dynamic equations that describe the relationships between position and velocity, and the equation for acceleration under conditions of uniform acceleration. This is dynamics in one dimension and the forces at work of weight and gravity. And these are high school physics equations, nothing complicated here. These calculations have made assumptions in favour of the official story. I've simplified it to make it easy to understand, but this is in favour of what they're telling us. No engineer or physicist would even consider making these assumptions that I've made and modelling this in the real world in any way that's truly accurate. Now, I've provided a diagram here. This is a graphical representation of the North Tower. This is the World Trade Center 1 building with the radio antenna at the top. The building has 110 stories, and it was 417 meters in height from the base to the top floor. The dotted arrows show the impact height of Flight 11 as it hit the North Tower at floor 93. Now, those people who have a background in occult, numerology, and gematria know the significance of the number 93. The loaded weight of the World Trade Center was approximately 450 million kilograms. The loaded weight of the entire building was 450 million kilograms, and each loaded floor is approximately 4.1 million kilograms. The height of each floor is approximately 3.81 meters. Now, in the next section of this table, we'll take the height of those 5 impacted floors above, which is approximately 3 to 4 floors that were damaged by direct impact. And for the sake of being conservative, we'll take sets of those 5 floors that were impacted, take them away. To simplify the mathematics, we're going to remove those floors and allow the top portion to come crashing down on the bottom portion, because this is how we were told that the progressive collapse or the pancaking effect took place. The World Trade Center is a steel framed building, not concrete. concrete floors as we've been told. So the story of the floors pancaking is a fairy tale because the steel structure of the building would not allow this. The structure was not concrete. And if you have to buckle steel that may have been weakened, as the official fairy tale tells us, then no one would model something completely removing floors entirely as if they do not exist. So let's stay on top of this, say that on top of this portion, the top portions of the building, dropping down onto the bottom portions of the building. We're also going to keep the impacted floors intact for weight purposes. In other words, what we're going to do is the next part of this table will explain, is the height of the 5 impacted floors. We're going to be looking at 9.8 meters, that is times 5 times 3.8. So 5 floors times the height of each floor at 3.8 meters. The plane is said to be hitting at floor 93, and that's the lowest estimate given that the plane impacted flight 11. The height of the lowest damaged floors was 93, which is at 354.4 meters. Now, taking the position of the building and the number of floors at or above the impact, which is the last part of this table, that's 18 floors, and then raising them up 19 meters, or the size of the 5 impacted floors, and then allowing them to drop with no resistance whatsoever onto the floors below. Now, as I've said, this is a radical assumption, but it is in favour of the official story. This is saying that the weight above is falling at an acceleration due to gravity with no resistance until it impacts the floors below, and at this impact point. Understand that by simplifying this model, we're going to give more credence to the official story. We're making a radical assumption in favour of that official story. But even with those assumptions, we will find out when we conclude that the official story cannot be true, regardless. So I've created another diagram here, diagram 2, that shows 18 floors disconnected as they were raised up at the height of 5 impacted floors, and the undamaged structure beneath of 93 floors that remain in Tower 1, approximately 354.4 metres out of the 417 metres of the height. Now we're going to take those numbers and put them into dynamics equations of physics. The basic equations of dynamics in Newton's law of motion can be found amongst any high school physics book. The first equation is V0 squared plus 2. So this is a dynamics equation that describes a relationship between position, velocity and acceleration under conditions of uniform acceleration or acceleration due to gravity. V is the final velocity, V2. And we're going to attempt to calculate this by plugging in the World Trade Center weights and measures. So V1 squared. The term V1 means the initial velocity, or the velocity of the upper block, the upper portion, or the upper 18 floors above. We know that this is 0 because they start from rest. And then we're allowing gravity to take over, to take effect. These floors smash down into the remaining floors. Mass times acceleration is acceleration due to gravity, which is 9.81 meters per second squared, because it's acceleration. Now D is distance, the displacement, or the height of the blocks that is falling, that we know, that we calculated. Now we are removing those 5 floors completely, which I said is a radical assumption, saying that there's no resistance over those 5 floors completely. But we're keeping all the mass of the building in those 18 floors. We're not actually removing them, we're just letting them fall through the distance of 19 meters or 5 floors. Again, a radical assumption in favor of the official story. Now, because I'm making radical assumptions in favor of the official story, This is what D represents here. We're attempting to solve now, since we have known on the right hand side of the equation, since we simply plug in those numbers and do the arithmetic. Now V1 is 0 squared, so it starts off at 0 velocity, and then we add on 2 times, which is 9.81 meters per second, times d, the distance, which is 19 meters. The result is the final velocity. When we calculate this, we add those two together, we take the square root, we do the multiplication, times add it to 0, and we take the square root of that. We will get 19.3 meters per second, which is approximately the velocity that the top block is moving when it meets the bottom floors underneath. Now, in the next equation, we need to understand Newton's second law of motion. F equals ma, or force is equal to the mass of the object multiplied by its acceleration. Now we're going to calculate two forces at work here, because between the upper falling portion and the portion it falls onto, Newton's second law, F equals ma. The forces which are labelled onto the diagram here, I've drawn a vector arrow to show that the direction of these forces, the direction that they're going in, and I'm taking down as a positive and up as a negative because the direction of motion is downwards. It is equal to the mass of the upper floors times the acceleration due to mass or gravity. Now we have 18 floors multiplied by 4 times 1.1 million kilograms, that's the weight of them, multiplied by the acceleration due to gravity, which is 9.1 meters per second, squared. And if we multiply those figures, we get 776,952,000 newtons. Newtons is a constant that represents kilograms times meters squared, meters per second squared, which is what we're working with the equation. That is the force carried by the upper portions of the building above the point of impact. The second force is resistance offered by the floors below that carried the upper portion for the lifetime of the building. They are built with safety factors in mind, not just on the edge of the weight carried by those floors. Because if that were the case, as soon as you start to load those buildings, the floors, then the building would collapse. They are built with significant safety factor in mind, and I'm sure that whatever those safety factors were, it is a very large amount, much larger than what I'm used to calculate. So once again, that's in favour of the official story. But even so, if we're taking the mass of the upper floors plus the safety factor mass, labelled as M, S, times acceleration due to gravity, when we solve for this, we get a greater number. But it is in the other direction because resistance is the force that is stopping it, because it is held by the upper portion of those floors there. Now that force, when you plug in the numbers do the calculation, is approximately 794,610,000 newtons. Now, we've analysed the forces behind the progressive collapse of this block. Our calculations have shown that it could not have happened as described, even with the assumptions in place. The mass on top could not fall through the material in just 11 seconds as observed. The steel could not buckle and collapse so quickly. without more debris at the bottom. Now, you do not see that because the debris blew away as dust immediately. It was completely pulverized into dust. Steel, concrete, office furniture, everything in the building just blew away across the southern Manhattan and across the river. Now, if we're going to use the two forces we've just calculated, and we're going to plug those into Newton's second law, we're going to find the acceleration at which the top block strikes the bottom block with. The sum of the forces equals the sum of the mass multiplied by the sum of the acceleration. We're solving for acceleration. That is what's the unknown. That's what we're looking for. So when we plug in these numbers and do the sums of the forces of these two calculations of F1 and F2 that we did previously, and we add those together, in other words, we're adding a negative force, so that is like subtracting, then we'll get a negative number at the top part of this equation. So we're looking at the deceleration. It means you have a deceleration when the upper part of the building strikes the lower part. And this is a negative direction because the acceleration, the initial acceleration starts at 0. And we're solving for the sum of the accelerations, the initial acceleration being 0, the final acceleration is being in a negative direction. In other words, the force is pushing back up again. And when you think about it, this is common sense. When a block at the top hits a block below, it will slow down. The amount that it will slow down will be 0.456 meters per second squared. That's acceleration. That's as it collides with the bottom portion of the building. If we look at the next diagram, the distance of the floors that are remaining, the impact below the point of impact, is 354 meters, or the height of what's left of 93 floors. We know the velocity in which the two portions of the building strike each other approximately, and we know the acceleration of the upper portion of the floors moving when it strikes the lower portions of the floors. Now we're going to plug those into another dynamics equation, dI, or displacement. That is, the upper part of the block needs to travel is equal to the initial velocity times plus half the acceleration times squared, or V2 equals V1 plus AT. The equation is another dynamics equation. Displacement equals the initial velocity times plus half the acceleration times squared. Everything in this equation we have solved for. We have the numbers except for the time. So we're going to now work that out. We're going to solve for time, which is a key factor to understand, which makes the official version impossible. So what we're saying is that the building could not have collapsed in the time that we saw with our eyes the building collapsing, which is 9.81 meters per second. They're telling us that due to this kind of collapse, it implies that this is structural deformation. The structural collision happened that could have caused it to collapse in that amount of time. And we observed it free falling. And when you solve this equation, you will understand that this is impossible. All of the supporting structural mass had to be removed by some unknown force at work for the building to come down at the time that we observed it coming down. It is not necessary to get into the whole debating and infighting about how this was done, because the proof lies in solving for the time aspect, and it came down in close to 11 seconds. This is an insanely conservative estimate for how long it would take, according to this model that I've just set up, that it does not even approximate reality in real life. And that's in favour of the official story. The displacement is 354.4 metres, which is the height of 93 floors. The V0 is the velocity that the top portion of the floors strikes the bottom portion at 19.3 metres per second squared, multiplied by time plus half the acceleration, which we calculated. So we see that we have a deceleration of 0.456 metres per second squared, multiplied by the time squared. Now I've kept this 3.354.4 equals 19.3 times t. Now we're calculating for t, so if you take 19.3 to the other side of the equation, so you divide it, 354.4 divided by 19.3, and we keep t, the result is minus 0.228 squared. So that's the time, and it's a negative, which proves that it could not have happened. I'm putting these into a different order. I'm taking the t squared variable and putting it at first, so it's negative 0.228 times t squared plus 19.3 times t. So I'm taking what was on the right hand side, rearranging the equation, the terms, to put it in terms of time. And I'm bringing 354 to the right side of the equation and bringing it over as a negative number that equals to 0. This is a simple quadratic equation, a simple second order polynomial. This is no more advanced than high school algebra. We get a result of the quadratic equation in the form of ax squared plus bx plus c equals 0. And in doing this, we know the formula to solve the variable in the second degree polynomial, or a quadratic equation, is this formula, which is x equals minus b plus or minus the square root of b squared minus 4ac, and all of that over a. Now we're not referring to acceleration with a. We're referring to the coefficient in ax squared. That is what these a and BAB and c represent. And this is the coefficient before t squared b. It is a coefficient b equals at for t. And c is the final term, 354.4. And when you plug all of those numbers into this equation, the result we get here is in the time in seconds that is required for that block to fall through the greatest path of resistance, even making these crazy assumptions that we calculate as 26.79, almost 27 seconds. And so we witnessed it happening at almost a third of that speed. And that is impossible. Now this next diagram, it does the same thing with the South Towers. So the South Tower was 110 floors. The approximate impact height of flight 175 struck at floor 77. And if you know about occult numerology, 77 is a significant occult number. The World Trade Center loaded weight, technically its mass. Kilograms is a measure of mass. It is 405th. The loaded weight of the tower is approximately 450 million kilograms. The loaded mass of each floor is approximately 4.1 million kilograms. The floor height approximately 3.81 meters. The height of the 5 impacted floors is 19 meters. The height of the lowest damaged floor is 77, and that's 292.6 meters. The number of floors above the impacted 30 floors. And these are all the basic measurements that we'll need for these equations of dynamics. So we're doing the same thing as we did before. We're taking the same dynamics equation, v squared equals v0 squared plus 2ad. We're solving for v, the velocity, the initial velocity. The initial velocity is 0, and acceleration due to gravity is 9.81 meters per second squared. So the displacement is 19 meters, or the height of 5 floors. When we get 19.3 meters per second, it was the same as with the North Tower. The resultant force equals mass times acceleration, Newton's second law of motion, and we're calculating for force 1. And there are the vectors that are shown applied to the building on the left. We calculate these forces and we get the result of 1.31 billion 367 million newtons, and this is in newtons. The equation Newton's second law of motion, F equals ma, the mass times the acceleration due to gravity. We have 34 floors times 4.1 million kilograms of mass per floor times 9.81 meters squared per second squared. The acceleration due to gravity, we get approximately 1.3 billion newtons, and the second force, which is a resistant force in the upward direction or in a negative direction, the floors are being built with a safety factor in mind to account for the mass of the floors above being loaded with people, equipment, etc. And I've calculated a low value for this. We have 34 floors times 4.5 million kilograms times 9.81 meters per second squared, and you get approximately 1.5 billion newtons in the upward direction or negative direction. So that's resisting the impact. Now plugging these numbers into Newton's second law again, we solve for acceleration. The acceleration equals the sum of the forces divided by the sum of the masses. We plug those numbers into force and plug the masses in, and then we get acceleration, which is the same deceleration rate as we did for the North Tower, which is negative 0.456 meters per second squared. The initial acceleration is 0. The final acceleration when the blocks collide would be 0.456 meters per second squared in the negative direction, or in other words, deceleration. Now, in this last diagram, I'm taking the knowns that we have solved for, which is the displacement over 77 floors, the initial velocity, the two of the top block that came down onto the lower portion of the floors, and the acceleration at which the top portion of the floors meets the bottom portion of the floors. These are known factors. We're plugging them into dynamics equations. Displacement equals v0, which is initial velocity, times time plus half acceleration times squared 0.58 squared. So the top portion collides with the bottom portion, 19.3 meters per second, times plus half the acceleration, and we saw the deceleration of minus 0.456 meters per second squared. So we arrange the terms, we get a quadratic equation in the form of ax squared plus bx plus c0. So we're solving for the amount of time that would be required for these top portions of the floors, that if you have the building, they would have buckled. Then these floors would have crashed into the floors below. We're doing this in a way that allows for and grants for huge allowances in favour of the official story. In this method of calculating, there would not be any way that an actual engineer or physicist would do this, because I'd never make these radical assumptions in favour of the official story. They would calculate those forces and vectors as close to reality as possible. And that would involve plugging in a lot more numbers and using computer modelling. But even if you did that, you still wouldn't get down to 10 or 11 seconds that we saw those buildings collapse. It ultimately comes down to the mass of those lower floors that were removed. This is an inescapable conclusion, and you will arrive at it based on the laws of nature. The upper portions of the floors fell at a speed due to gravity, meaning there was no resistance or force opposing them. You need to come to an inescapable conclusion that the collapse of the towers was a controlled demolition. There is something even beyond that at work that removed all of these floors, all that resistance. And whatever it was, it didn't leave any debris, or much debris there over those 93 floors. The dynamics equation, D equals V0 plus 1/2 of 80 squared, which is on the diagram, it's in green, the last page. We're plugging it into the numbers. We get a quadratic equation, which is -0.22. So minus 0.228 t squared plus 19.3t minus 292.6 equals 0. This is a simple quadratic equation, or second order polynomial in the form of x squared plus bx plus c equals 0. Solving for the variable, we use a formula presented in the diagram. It's in a white box there. It's a formula to solve the quadratic equation. We get t equals 19.78 seconds. That's an extremely conservative estimate. So time equals 19.78. There's no way that we could have done that in reality, but it's still twice approximately the amount of time as in the first example that we saw, 3 times the amount of time that we witnessed with our own eyes. And the images that were played out on TV on that day. And this is almost twice what we witnessed, is 20 seconds. And this is impossible unless you're completely pulverizing into dust all of the resistance in those floors. Now, what could possibly have done that? The inescapable conclusion that you would come to is that there's some other force that was applied from below. So something caused the floors below to collapse. And it wasn't due to the weight of the building, the floors on the top impacting on the floors below. And when you see the evidence of the molten steel at the bottom in the basement that burned for weeks afterwards, you can see that some kind of energy weapon was used. Yet I'm not speculating as to what that is. This isn't a typical controlled demolition. The mass is not accounted for. Not even thermite would do that. You would still have a lot of material left over. It would not have disintegrated. It wouldn't have blown away over the Manhattan and the river. So what did happen?